So from the Python Advanced, we can start with the OOPS concept, which is like the foundation of the Python Advanced. Okay.
Mhm.
So now we have already discussed what is OOPS and what is classes and what is object. Okay, so we can take a quick revision on the classes and objects. Then we will move to the advanced concept. Okay. So first we have this concept which is modular programming and procedural programming. So what is modular programming? So in the procedural programming, it can be defined as a programming model which is derived from the structured programming based upon the concept of calling procedure. So procedure is also known as routines or subroutines or functions. So they are like whatever we were doing up to here, that is procedural programming. We are following a certain procedure or we are following a certain functions or routine. Like we are creating functions, we are creating multiple functions. So that is a common or we can say a basic way of programming where we are creating functions, we are creating loops, we are creating like variables and so on. That is our basic approach. So that is procedural, which is like from top to bottom. So we are going from top to bottom approach. First, we are creating the program, like creating the functions. Then our code is running from top one after another, line by line, and up to bottom. So that is procedure. So procedural programming does not have any proper way of hiding data, so it is less secure. So in the procedural, we don't have any way of hiding the data. Okay, like what is hiding, we will discuss later. But for hiding means we wanted to hide implementation from the users. We wanted to hide some variables, some functions, maybe some part of the program from the users or from the developers. Or we wanted to hide some variables, or we wanted to make any variable that is inaccessible to other users. That we can do with the help of modular programming, not with the procedural programming. So first, procedural is like combination of functions we are creating. It is a top to down approach, and we cannot hide data in that programming, and it is not suitable for the real world problems. Okay, so let's say we are creating any like solution for any problem. We are creating any program, we are creating any, we are developing any application. So this mechanism is not good for the real time scenarios. Okay, then this programming is used for designing medium-sized programs. We can create a basic and medium-sized program. Okay, and we can use code, like we can reuse code in the procedural, but not in the high level. We can use some code, like we can use some functions and we can reuse the functions, but we cannot do this in the high level. Okay, and with the help of this procedural programming, we cannot create a real-time programs. We cannot solve any complex problem. So that is procedural. Okay, so up to here, we were following this approach, which is procedural programming, a normal way. We are creating functions, we are creating multiple functions, we are running the code and so on. Now we are going to follow the second approach, which is modular programming. So in the modular programming, we are creating the objects, the classes, and so on. Sorry, not modular. Modular programming is like whenever we are creating the modules. Yeah, that is modules. Like for example, we are creating the modules in the other file. And now we are importing those modules in our main file. That is a modular program. We are dividing the program. We are dividing the entire, let's say we have an entire, let me draw this. Let's say we have this entire program. Now we are distributing the part of the program. This is one module. This is another module. And this is third module. So this is one module, second module, and third module. And let's say this is my main file. Now in my main file, I am importing the module number one, the features, or we can say the functions of module number one. I can import the functions, the methods, the variables of the module number two and module number three. That is modular programming that we like already discussed. We can like create multiple modules and we can import in our Python file, in the main Python file. So how this will help us? It will like we have a pre-existing functions. We have the pre-existing modules which is created in another file, and we can simply import those functions in our file. Like we can simply run the function. We can call the function name without actually defining the function. So that is why modular are useful. It will we can have a simple file, our main file. In the main file, we can import many modules and we can perform the functions. So it will hide the complexity of the main modules. Okay, so that is modular programming. So modular programming is the process of subdividing a computer programs into separate subprograms, or we can say separate files or separate modules. Okay, that we have discussed in the modules and objects. Then a module is a separate software component, or we can say it is a separate file. It can often be used in a variety of applications and functions with other components of the system. For example, let's say we have a module, OS, operating system. Okay, we have discussed this operating system module. Now we can use this module in multiple programs. We can use this module in multiple applications, in multiple files, in multiple programs, and in multiple functions. So we can use this single module, which is OS, in multiple files of Python or anywhere we can use. Okay, so modules are same, or we can say libraries or frameworks, etc. They like all follow a same method, which is modular programming. Similar functions are grouped in the same unit of the programming code, and separate functions are developed as separate units of code so that code can be reused by other application. As I said, let's say we have different modules. We have random module, we have date time module, we have operating system module, we have a regular expression module. So we have many modules. So they're like a single file, or we can say a couple of files, multiple files. And we can use those multiple files into our main program. And we can use this module anywhere we want. We can simply just import the module and start using it. That is like the benefit of using modular programming. This is also we have already discussed or already used, like how we can create modules, how we can import it, how we can import OS module, random module, or datetime module, and so on. Is it clear? These two
Mm-hmm.
approaches. Now, next approach, we have this object-oriented programming approach. That is now this approach we are now going to follow. So it is like it is another like approach of solving the problems or writing the program. So object-oriented programming can be defined as a programming model which is based on the concept of objects and classes, where we create classes and we create objects. Objects can data contains data in the form of attributes and code in the form of methods. Um, objects can data that is not objects, that are classes. Let me mention that. Objects and classes contain data in the form of we have this attributes like variables, we have functions which is known as methods inside classes, and that object can be we can use that object to access the attributes, the functions, the methods of the classes. Okay, in the object-oriented programming, computer programs are designed using the concept of objects that interact with the real-world applications. Now, what are object here? If we discuss what is object, object is anything. Okay, any object. Let's say you are driving a car. Car is object. You are using any application to make payment. That application is a that application is a object. So we have multiple objects. Object can be anything. You can create as many as object you want. Let's say you are creating a program to, let's say for any school or for any college. So
Mm-hmm.
school is object there. And let's say you are creating any like application for uploading files. So that application is object. Okay, let's say you are creating any program for the student. Student is object. So object can be anything. It can be anything. Okay. So object-oriented programming language are various, but the most popular ones are class-based, meaning the objects are instances of the classes, which are also determined their types. So we are going to follow the class-based object-oriented programming, which is we have the class and we have the object. Classes are contain the blueprint, contains the attributes, methods, and objects are the instance of the class, which means with the help of objects, we can access the class, we can access the attributes of the class, and we can access the functions of the class. So in the object-oriented programming, the program is divided into smaller parts called objects. So we have some benefit here in the for using the OOPS here. First, it follow the bottom-up approach, not top to bottom, but bottom to top approach. Okay,
Mm-hmm.
first we have object, then it will read the classes. Okay, so that is bottom to top approach. Secondly, it is helpful for using, we can say it is helpful for using the data hiding or it is more secure than the procedural programming. Then it is based on the real world. We can create real world application with the help of OOPS. We can design complex programs, large programs, and multiple programs with the help of OOPS. Okay, and we can reuse code in the OOPS in a better way. In the procedural, we can also reuse the code, but that is not in the efficient way. But in the OOPS, in the object-oriented programming, we can reuse the code in a more efficient way than in the procedural programming language. So these are the benefits of object-oriented programming over the procedural programming. If you see Python, like if we analyze Python, what is Python? Python is a programming language, right? Inside Python, we have data types. We have strings, we have numbers, we have integer float, we have list, tuples, dictionary. Those are all data types. But those are not data types. Those are all objects. So which means Python is already made up of objects. Whatever you see in Python, they're all objects. So objects and classes are the base of any programming language. Maybe mainly the high level programming language like Java, C++, Python. In the Python, everything is object. Everything. Whatever we are discussing, let's say we have discussed about the length function. We have discussed about like sorting. We have discussed about many functions, print. Those are all objects. So like in the Python, objects and classes are the base. Everything is made up of objects and classes. So with the help of objects and classes, we can create any sort of data type. We can create data type. We can create our own data type. We can create our own functions like large functions. We can create our own applications and so on. So OOPS are like a very powerful and very important concept of any programming language, mainly the high-level programming language. Is it clear, the concept?
Yes. Yes, teacher.
Okay. So this is what we are going to discuss, which is OOPS. Okay. Now, so let's take a first revision on the OOPS. In the OOPS, we have discussed about the classes and objects. So let's create a class first. How we can create a class? We can simply use class and name of the class. Let's say class name is students. This is my class name. Then I can create variables here. I can create variables. Basically, we can say they are variables, or we can say they are attributes. So we can say anything. We can either say variables or we can say attributes. So let's say the variables here are roll number. Let's say 1, 2, 3. Name here. Let's say ABC. Or we can say branch. Let's say is computer science. Okay, CS. So we have this class. In the class, we have 3 attributes, which are roll number, name, and branch. Basically, these are variables, but we are using inside class. So they have a special name, which is known as attributes. So they are not variables. They are known as attributes. Okay. Then we have method. What a method? Method is just function only. They are just function. So we can use def and then let's say read. Read is a function here, which will take self as a parameter. And then we can print here reading. So here you can see this is function. This is simple function, but we are creating this function inside class. So what it is known as method. Okay, so this is known as method. So we have this class, a very simple class containing some attributes and one method. Now we can create object. How we can create object? Simple object 1 equal student. Okay. Now this is my object. So object 1. If you see object 1 is equal, it is a variable only, object 1. But it is containing, what kind of value it is containing? It is containing the entire class, which is this one. So that is why it is known as object. So obj1, it is an object here, not a variable, because it is containing the entire class. Then we can print the values. Let's say we can print ABC.
Name.
Just a second. Let me mention the string roll number. So this is for the roll number. So we have object 1 dot roll number. Okay. Then we can copy this one and we can paste. Second, we have this object set1. We can access name. Then here we can access branch. Same as here we can put name and name. Okay, now we can call this function because it is a function defining. We have to call it. Calling is important. So we can call this function. We can use print or we can simply use this object what dot read. Read is my function. So I'm calling my function. So let's save this file on desktop. Let's say advanced oops dot py. Okay, now we can run this one. You will notice roll number, which is 123, name ABC, branch CS, computer science, and it is reading. The student is reading. Same as we can create another method. So we can create as many as method we want, and we can create as many as attributes we want. That is like that's we can do in the class. Let's say I can create another method. This is method number 1. Now let's see we have another method. Method second. In this we can say def, let's say write, which will take self as a parameter. And then here we can print writing. Simple. So this is writing. This is method number 1, and we can access the writing. And we can run this one. Now you can see reading and writing. It is just printing as it is. It is a very simple class containing the attributes, the methods, and the object. This is object. So we can name this object. Same as now, now what is reusability here? How we can reuse this class? We can create another object. Okay, we can create another object with the same name student. Now again, we can access the elements. We can print. Okay, we have this object 2 or roll number, which is 1 to 3. Even here, we can change the roll number here. For example, let's say object 2 dot r number equal 456. Okay, now what is the current roll number becomes 456. So we are changing the object to roll number, which is 456. We are not actually changing here. We are not actually changing here. We are changing in the objects. So if I run this one, you will notice 456 roll number in the object second. In the first object, it is 1 to 3 only, but in the second object, it is 456. Same as we can change the name, we can change the branch and so on. So we have the reusability here. We can reuse one class again and again with the help of multiple objects. Okay, so this will save the space and this will save the time. Is it clear? The concept of classes and objects?
Yes, teacher. Wow.
This we have already discussed, how we can create classes and how we can create objects. Now we can move to the advanced concept, which is known as inheritance. Inheritance. So as the name suggests, inheritance means inheriting any feature, any any feature or attributes or methods from any other class to our class. Okay, let me show you the definition of inheritance. It is just extracting or sorry, inheriting the features. Yeah. So inheritance is a capability of one class to derive or inherit the properties from the another class. The benefits of inheritance are, for example, let's say we have two class 1 and class 2. Class 1 is a superior class 2 is a let's say lower class. So now what we can do, we can define our functions, we can define our method in class number 1, and in the class number 2 we can extract or we can derive the features or the methods or the functions which we have used in the class 1 in the class 2 without actually creating them. That is inheritance. Okay, let me show you an example, a very simple example to understand the definition. Let's say we have the class parent. Okay, parent is my class. Okay, here let's say I'm just using a function def t display, which is parent display. Okay, let's say we are taking this self here as a parameter, and let's say we are printing here parent. Simple. It is a class. Let me comment this. So we have a class which is parent, and inside parent class we have a function which is this p display. Then we have second function here, which will take again no parameter at all, which is self is a no parameter, and here we can print here. Let's say another function. This is my second function within my same class parent. Now, what I can do, I can create now another class. This is one class. Now I will create a class with the name of child. Child is my class. Now this child will inherit or derive the features from the parent class. See, this is what is mean by inheriting, or we can say deriving. So here you can see we have parent class. Now this parent class I am using in the child class. This one. Here you can see. Now let's say we define any function here that C display, which is child display. It is another function. We can take self and let's say print here child. So now we have two classes. First class is parent class, second class is child class. Now I will create a simple object here. Object. Let's say I'm creating the object for the child class. So that is C, child underscore object. So this will take class as a child. Okay. Now what I can do, see, this is my single class. I can access this function from my class. That I can do. Okay, that is obvious because this function is inside my child class. So I can easily access this function. So I can use here C dot C, sorry, child object dot C display, which is child display and so. Okay. So if I run this one, you will notice child. Okay, that is okay. That we were doing previously. But what if I can access the features of the parent class as well from the child class? That I can do. If I write here child underscore object, and I can use p display here. Now, what is p display? Where is p display? P display is inside parent class. So we have first class and then we have second class. So from the second class, I am accessing the features of the first class. That is what it means by deriving. If I run this one, you will notice parent. I have a parent. Even I can also access this particular function from the parent's class. So what I can do, I can again call the class child object dot this function. So I can run this one and you will notice another function. So first thing is I can access the objects, or I can access the functions or methods or whatever attributes from the child class because it is my main class. But what I am doing additionally is I can also access the functions, which is this one and this one from the parent class as well, from the child class. I'm not creating any parent class. This is my child class only. If I create another parent class, parent underscore object, this is my parent object where I will create parent as a class. Now, this is my parent object, but this is my child object. And I am accessing child class only. But from the child class, I can access the features of the parent also, which is pre-discipline function. That is means by inheritance. I can inherit the feature, the attributes, the methods of the parent class to my class without actually writing it. Okay, see, if I remove this one, if I remove this parent from here, now you will see we will have this error. If I run this one, you will see we have this error, which is this one. Here we have this child here because child is, we are taking this from the C display, from the child only. But P display is not accessible now because child object has no attribute P display. We don't have any attribute P display here because P display is in the parent class. And now I cannot access it because I'm not inheriting. I'm not deriving. So what I can do, I can again write here parent. Inside class, I can write parent here. Now I am I can inherit the P display and fun, another function from the parent to my class. If I run this one, you will see we have this parent, child, parent, and another function. That is like how this inheritance work. We can inherit the features of our parent class. So this class will become the base class. It is known as base class because it is the base. And this is the derived class. Okay, why it is a derived class? Because it is deriving the features from the parent class. That is why it is a derived class. Or we can say child class. It is a parent class because it is higher in the higher position, and it is a
Mhm.
base class. It is becoming the base of the child class.
Mhm.
Okay. Is it clear this concept?
Yes, teacher.
Okay. Even we can also access, we can create a parent class also. Like for example, parent object. We can create parent class and we can access the parent object. Okay. Now I'm accessing the parent display, which is this one from the parent class,
Mhm.
and fun from the parent class. But
Mhm.
what I cannot do is parent cannot access the child object.
Mm.
Parent cannot access the object of the child, means the features of the child. That is not possible. Okay, like child can inherit the features of the parent, but parent cannot inherit the feature of the child. Okay,
Mm.
so if I run this one, you will see no error. But what I cannot do is I cannot like write this one parent object dot C display. C display is where inside child class. So parent
Right.
cannot inherit the features of the child class. If I run this one, you will see error here. This is an error.
Mhm. Oh.
I can write here for the for future reference.
Mhm.
This line will throw the error because the parent class cannot inherit the features.
Mhm.
Whenever I'm saying features, features means the attributes, the variables, and functions only.
Mhm.
Inherits the feature, the child
Plus.
class. Okay, so this line will throw the error. Child can inherit the feature of the parents, but the parents cannot inherit the feature of the child.
So
Okay,
teacher,
and here,
if so, teacher question. So if the class parent, you put this open and close parenthesis with the child, so you can still you can access now this the parent the child, right, the print child see display.
yeah, let's see. Let's see this one. Okay, we have this child here.
Yes,
Now we have this child, and now each parent and child is inherits its own
correct.
properties. Okay, now we get uncommon sign. So this will
Yeah,
throw
that's
the error. We can
oh
see child is not defined. Why? Why child is not defined? Because we are defining the child after parent. After
correct.
parent. We are not
That's
defining before parent. So the
mm-hmm,
parent class will think where child is. Okay. So
mm-hmm.
that is why parent class is known as base class. It is a base. It is coming first. That is why.
Mm-hmm.
Okay.
I understand, teacher. Thank you.
So this is inheritance. Whenever we are
Mm-hmm.
inherits the features from the child class, features of the parent to the child class. So we have some benefits here. First, it will represent the real world relationships well. So let's say whenever you are creating any application, let's say your application is you are creating a payment application, okay, like PayPal. So there's a login page. Okay, login and sign up page. Now you wanted to connect the login and sign up page together. So how you can do? You can do with the help of inheritance. So in the real world application, you can define the relationships between different classes with the help of inheritance. Okay, so what here we are doing? We are defining the relationship only. This is parent and this is my child. Now these classes are related to each other. There's a relationship. Okay, there's a relationship. So this is relationship. It represents the real world relationship well. It provides reusability of a code. We can reuse the code. For example, here you can see, we have two classes, two functions here, display and fun here. Now I am inherits the features from my parent class. So whenever I inheriting, I didn't write the parent class here. I didn't mention the display or fun function inside my child class. So without writing, actually I can easily like take the features from the parent class as well, which means the child class can take the feature of its own, as well as the child class can take the feature of the previous class without actually writing it. Okay, I'm not writing this function inside child class. I'm not writing this function. inside the child class. I can easily access without actually writing it by just simply using parent here. So without actually writing, we can access functions and methods. So there's a reusability of the code. We can reuse this function and this function in the child class as well. So this is a reusability. We can simply reuse it. Then it is transitive in nature, which means that if class B inherits from class A, then all subclasses of B would automatically inherit from class A. Like it is like saying it is following the top to bottom approach. If which means if class B inherits from class another class A, it is like a see, we have classes. Let's say we have class A, we have class A, we have class B, and we have class C. Okay, let's say the class B. Class A is a parent class here. Okay, parent class. So now class B is a child class. So class B can inherit from the class A. That is possible. So whatever the features are in the class A, we can access, the class B can access. Now let's say the class C is also, it is now inheriting from the class B. Now let me write A here. A. Okay, it is a child class. Now let's say class C inherits from the class B. It is inherits from the class B. It is again a child class. So now class C is inheriting from the class B, which means this particular line says, so the class C can also take the features of B as well as the features of A, both. Okay, so the class A is a parent class. Class B is a, let's say it is a parent class. Class B is a middle class, and class B is taking features which is inherits from the class A. So class B can access the features of class A. Okay, class B can access the features of class A. Then we have another class C, and this class C is inheriting from the class B. Now class B is also inheriting from class A, which means there's an indirect relationship between C and A. C can also take features of class A, and C can also take features of class B. Think of A is a grandparent, B is a parent, and C is a child here. Okay, so a child can inherit from the grandparent also and from the parent also, like the features, the genes. So that is what this line says. Okay, so it is known as a multi-level inheritance. Is it clear, this concept?
Yes, teacher. Yes, teacher.
So what we have discussed here, this one, this is an example of a single inheritance. Single inheritance, which is a default or basic inheritance. So in the single inheritance, we singly there's a relationship between there's a definition here. Single inheritance, when a child class inherits from only one parent class, it is called single inheritance class. When a child class only inherits from only one parent class, that is single inheritance. Then we have multiple inheritance. In this, a single child class inherits from a multiple parent class. Okay, let's say a single class, which is, let's say, we have class A, we have class B, we have class C. Now, class C is a child class here, which is inherits from class A and class B both. And this is class A is again a parent class, and class B is also a parent class. So there's no relationship between A class and B class, but there's a relationship of the A and C and of the B and C, because C is a child class, and this is the mother and this is father. Okay, like two parent. So this child is taking inherits from the A class and from the B class, but there's no relationship between A and B. Okay, there's no relationship between A and B. We have the relation between A and C and B and C. That's it. That is multiple inheritance, where a single child class inherits from two classes at the same time. Then this is multi-level inheritance, when we have a child and grandchild relationship. Same as if we have A, we have B, and we have C. A is a grandparent here. Let's say it is a grandparent. B is a parent, and C is a child. So if B is inheriting from the class A and C is inheriting from class B, so there's a indirect relationship between C and A. Okay, because it is a grandparent, it is parent, and it is child. So C, which is a child, is inheriting from class B, but it can also access the feature of class A as well. Okay, that is multi-level inheritance. So we have three types of inheritance: single, multiple, and multi-level. Let's take this example, which is here. We can copy this one.
Mhm.
It is a wonderful example. See, here we have a class employee. Okay, class here is a employee. Employee is a base class. Base class means parent class. So in the employee, we have one feature, like one variable here, which is company Google. Okay. Inside employee, we also have one more function, which is show details. And it will take no parameter. Self is just a like compulsory parameter, which is printing here. This is an employee. So we have a company named Google, and we have a function which is show details. This is an employee. It is a parent class. Now here you can see we have another class, programmer. Programmer is a child class. Why? Because here you can see the bracket, it is inheriting from the employee class. So here we have child class. Child class is also known as derived class. Okay, because it is driving the features from the employee. Yes. So here you can see we in the programmer class, we have another variable which is language Python. Okay, we have language Python. And then we have this def get language self here. So we have one more feature which is get language. And then we have second feature, second function, which is show details. Now here, if you notice, we have two functions here in the programmer, which is show details and get language. In the class, first class, which is parent class, we have one feature only, one function only, which is show detail. This function of show detail and this function are same only. Okay, they are same. But you can read this line, this particular line. This is an employee and this is a programmer. So there's a change. Now this function and this function, they are not same. Okay, basically, see, function name are same only, function name are same, but the value, the functioning of the function is different. This function is printing this is an employee, and this function is printing this is an programmer. So these functions are same, sorry, different. Now what we can say, see, our code will flow from top to bottom. So here you will notice, here we have this language here. Let me show you an example first. We are creating a class here. Okay, sorry, object here E. E for employee. So now here we have an employee. Let me remove this part. Yeah. We have an employee as a object here. Okay. And this employee, which is this one. This is here we are printing show details. So what it will print? This is an employee because we are accessing from employee, we are accessing the show details function,
Mhm.
which is this function show detail. So it will print this is an employee. Okay, so let me comment this part. And if I run this one, you will notice this is an employee because
Mhm.
we are creating the class of the employee, which is our parent class. And inside parent, we have the show details here. Okay, that is okay. That is simple. But let's say now I'm creating another object, which is P. P is a programmer here. Okay, it contains programmer class. And programmer is a child class here, which is inherits from the parent class employee. Now, if I access show details here, if I access show details here, what it will print? It will print this is a programmer. Why? Let me tell you why. See, this is a programmer. So what we are doing, see, if I remove this function from here, if I remove this function from here, okay, now what it will print? It will print this is an employee. Why? Because we have a class programmer. Programmer is inheriting from the class employee. Inside employee, we have a function show details. So a programmer can access the features of the class employee, which is show details or company. So if I print here show detail, it will print this is an employee. This is an employee. You can see this is an employee. But
Mhm.
I'm creating another function with the same name as my parent class, which means I'm updating the function. I'm updating the previous function in my parent class to the child class. Okay.
Mhm.
For example, let's say you can think of a very simple example. Let's say we have a parent class and we have a child class. The parent class, let's say the parent favorite color is red. Let's say red color. Now, but child have different red color, different favorite color. Let's say the child favorite color is black. Now the child can also change the features of the parent into their own class. Okay, let's say the parent favorite color is red, but when the child comes, the favorite color of child becomes black. So there's a change in. We have the same property. Red color is here and color is here, but the value is changed here. In the parent we have red color, in the child we have black color. Same is happening here. Here we have the show details. We are creating the same function name here, but we are updating the value here, which is this value. In the function, we are using this is an employee, and here we are using this is a programmer. So the child class has updated the future of the parent class. Now it will print this is a programmer. Okay, same as if I run the company. See, if I print this get language is a function here, let me print p dot get language. Okay, what is the language here? Python. Okay,
Mhm.
so this is like a common, like this is a single function. So it will print the language is Python. See, the language is Python here. But if I if I wanted to access the company, let's say the parent is working in the Google. Now the child is also working in the Google. If I print here, print p dot company. Okay, which is programmer.company. So what is the company of the programmer? We don't have any company here, which means the child is also working in the Google company. If I run this one, you will notice Google here. But let's say now child is working in different company, let's say YouTube. Now child updated its parameter as a company here, and now the child is working in the YouTube company. So now you will notice YouTube here, which
Mhm.
means we are updating the values with the same variable name, with the same function
Mhm.
name. We can update the features of the parent class in the child class.
Mhm.
Okay, is it clear? Like how
Yes,
it is
teacher.
working?
Yes, sir. Yes, teacher.
So, and employee details is simple. We have this show details. If I run this one, print e.company, you will notice Google only because parent is working in the Google. You can see parent is an employee and it is working in Google. Okay.
Oh, you
So
can
this
still
is
add the pin. Okay.
So this is an employee class where we have show details and print because employee is not inherits from any other class. It is a base class or parent class. It cannot
Mhm.
take any feature from any other class. But programmer has extra privileges because it is a child class and it is taking the feature from the parent class.
Mhm.
And it can also update the previous parent feature in its own class. For example, we are updating the company Google to YouTube here. Same as we are updating the feature show details to the employee program here. This is an program. So this is known as single inheritance, where we are inheriting from a single parent class.
Mhm.
Okay. Now, then we have multiple inheritance. So let's take an example of multiple inheritance. Now, what is multiple inheritance? When a child class is taking the inherits from the two parent class. Okay.
Mhm.
Or we can say two or more parents. So that is multiple inheritance. So let's say we have a class, mother. Okay. And we have def, let's say m display, which will take a self parameter. And here we can run print mother. It is first class. Then we can create another class named father. And we can create f display father. So we have two classes now, mother and father. Now we can create a class child. Now child will inherit from the mother and father both. So here I will put mother, comma, father both. Okay, so the child is inherits from the mother and father both. And here we can create another function for the child, separate function child here. So now we have three class. One class is mother, father, and
Mhm.
child. Now child is inherits from the mother as well as father both, which means which means the child can access the future of mother as well as father. But the father cannot access the future of mother, and mother cannot access the future of father. So there's no relationship between mother and father, but there's a relationship between mother and child and father and child. Okay. Now we can create a object which is C equal child. And we can simply use C.display, which is child, is now accessing the future of mother, which is M display. Same as child is accessing the future of father. And the child can also access its own feature. Okay. So if I run this one, you will notice mother, father, and child. So the child has the privilege to access the features of mother class, father class. But if I write here, let's say equal father. So father cannot. Here we get its father, and here we can print f display. The father can access their own feature, which is f.display, which is we can see
Wait,
father at last.
yeah,
But
teacher.
father cannot. Yeah.
Yeah, there you
Do you
go.
want to ask something?
Yeah, so father can access the mother, huh? Yeah, M
Yeah,
display.
father cannot access the mother features, which is m display. If I
Yes.
run this one, you will see the error here.
Oh.
Father object has no attribute m display. Same as mother cannot access the features of father. Let's say we have this another class m here, and we have this class mother, and here we have this m dot m display and m dot m display. Now here you can see this line will throw the error because mother cannot access the feature of father. So if I run this one, let me uncomment, you will see the error here. Mother object has no attribute f display, which is father. So mother cannot access the feature of father. Okay. But a child can access the feature of mother and feature of father. This is known as multiple inheritance.
So
Is
I
it
thought,
clear?
teacher, I thought the father can access the mother inheritance, huh? The M display. So no, so it's not.
Yeah, it's not possible.
Okay.
Because you can see here, it is very obvious here. K class mother, K class father. But in the child class, if you notice in the child class, we have mother written here and father is written here, which means child is
Oh.
accessing the feature of mother and child is, sorry, child is accessing the feature of mother and child is also accessing the feature of father. It is written here, okay, in front of us. Sorry. But a father here is not accessing any of the feature, you can see. Same as
Correct,
mother is
correct.
not accessing any of the feature. Okay.
Mm-hmm.
So this is known as multiple inheritance.
Mm-hmm.
So let's see if we have any other example. So you can see there's an example here.
Mm-hmm.
It's not there. So we can copy this example. So here you can see we have a class freelancer. Okay, it is a class freelancer, and this freelancer is working in a company Fiverr, and the level of that freelancer is 0. Then we have another class employee. This employee is working in the company Visa and e-code. Let's say some e-code is there, which is employee code is 120. Okay. Now there's a programmer here. There's a programmer here. Let's say I am the programmer. Okay, I am the programmer. Let's say we have one person who is a freelancer, and let's say we have second person who is a employee. But now I'm a programmer. I'm a programmer who is a freelancer also and who is a employee also. I'm working as a full-time employee also in the visa company, and I'm also working as a Fiverr as a freelancer. So now I'm a programmer, which inherits the feature of freelancer as well as the employee here. And my name is Rohit, let's say. Okay, simple. Now we can create a class programmer, and we can also create a class employee, and we can also create a class freelancer. There are 3 classes here. Now let's say I just want, I'm the, let's say I am the programmer. So let's say I just wanted to access my company. Okay, like my company. Now here you can notice we have two company here, company Fiber and company Visa. So which you will think it will print?
The employee, the visa.
Exactly. It will print. Sorry. Yeah, it will print Fiber. Why? Because
Oh,
here we are using freelancer first. That is why. Here we are
oh,
using freelancer first. That is why. And then we are using employee. That is why. See, if I reverse this order, first I will take here employee and then I will take freelancer. Then it will print visa. We have this employee and then we have this freelancer. Now it will print visa because which I'm accessing first. I'm accessing employee first. So it will print visa. And then I'm accessing freelancer. So when I print p.com programmer dot company, so it will access the first occurrence, which is employee visa. So if I
mhm,
run, you will notice visa here. Okay, visa. So it is
mhm.
as per the first occurrence, which we are using first. Okay, it is not about top to down approach.
Okay,
So
gotcha.
same as if I print here the E code and I can print E dot level and then I can print P dot name. So name we have Rohit, level we have 0, E code we have 120. Everything as it is. But company we have visa here because we are using employee first and then freelance. Same as now employee. Employee is this one. Now employee is not taking any property from the freelancer or not from the programmer. So employee here is a parent class. So here we can write it is a parent class, which is also known as base class. Same as freelancer is also a parent class, which is known as base class. But this programmer is a child class,
Mhm,
which is also known as derived class. So we can create employee. Employee can print. Here we can print E dot, which is employee dot company. So this will print the employee company. Okay, employee company, comma E dot employee E code. So this will print employee company visa and E code is 120 of the employee. Okay.
there you go.
Then we can print the company and the level of the freelancer. You can copy and you can paste. Now we have this F dot company of the freelancer and then we have this F dot level. Simple. That is straightforward. We have this Fiverr and 0. But employee programmer is inherits from the employee and class with the same name company. So it will take the visa because employee is coming first. If I put
Mhm,
employee after freelancer, then we have people. Okay.
mhm.
So this is another example of multiple
Alright.
inheritance.
Mm.
Any questions?
No, teacher. Good, thank you.
No. Then we can move to multi-level.
Mhm,
You know, now multiple inheritance is when we have three classes, which is child class, then we have parent class, and then we have we have grandparent class, we have parent class, and then we have child class. So let's see. It is again very straightforward. We have class,
mhm,
grandparent. It is my base class, which is parent class. Okay. Now here I can use def dot g display, which is grandparent display. Self here I can use print grandparent. This is grandparent. Let's say the color of the grandparent, the favorite color of grandparent is, can write here self red. Okay, let's say red. Okay, now we have another class, which is class parent. Now this parent class is will inherits from the grandparent class. Okay, so we can write here def P display, and here I can use self and print parent. Now, then I have class child. Child is inheriting from the parent class, simple parent class. And then we can use C display, and then we have child. So now you can see here, we have three classes: grandparent class, parent class, and child class. Grandparent is like a base class, which is overall parent class. Parent class is again a kind of a combination of, we can say, parent class and child class both. So this parent class is parent and child class both, because parent inherits from the grandparent. Okay, so that is why it is a child class. But why it becomes the parent class? Because another child, there's another class which inherits from this particular class. So that is why this parent class becomes child and parent both. Okay, at the same time. Then we have this child class here. So child class inherits from its parent class. Simple. So it is like a hierarchical structure. We have the hierarchy here. Now we can create a child as a object here. Now child can access G display, child can access P display, and child can access C display, which is this child. This child can access the properties of the parent class, and this child can also access the property of the grandparent class. Okay, so if I run this one, you will notice no error here. Grandparent, parent, and child. Now the child can also access the color of the grandparent. Let's the child favorite color is red only. Okay, so here we can use C.child. So now you will notice red color here. Okay, that is child class. Now let's say we have parent class. We can use P equal parent. In the parent class, let's say the parent can access G display, parent can access color, and parent can access P display. But parent cannot access the C display because parent cannot inherit from the child class. Okay, so it can access G display, P display, and it can access the color. So a parent can also access the grandparent, parent, and red color. A parent cannot access the child. Okay, a parent cannot access the C display, which is child properties. That is impossible. Then we have grandparent. Grandparent, what grandparent can do here, which is equal grandparent class. So we have G display and color. So the grandparent can only access its own property. A grandparent cannot access the property of the parent class and the child class. So the grandparent can only access the property of G display and color only. So if I run this one, you will notice grandparent and color. Right. Okay. Now let's say after some time, the child wanted to change the color. So here we can create another function here, def color, with the same name, and I can use a cell. And now the color here is blue. Now the child favorite color is blue here. Okay, child favorite color is blue here. So if I run this one, you will notice blue color of child. Okay, like favorite color of child is blue here. And rest, the parent color is red only and grandparent color is red only. But the child change its color to blue. Okay, so a child can change its properties, sorry, its parents' properties. Okay, a child can change the property of the parent class, and also the child can change the property of the grandparent class. Okay, now let's say we can paste this particular part here. Let's say the favorite color of parent becomes blue. Okay, now can you tell me which color the child will choose, red color or blue color?
Blue.
Yeah, blue color. So you can see it is still accessing blue color because it is the favorite of its near class, which is parent class. And also now the child can also put its own color. Let's say the child color here is black. Now each class has its own color: black color, blue color, and red color, like this one. Okay. So this is an example of a multi-level class. Make sense?
Yes, thank you
Any
very
question?
nice. Nothing. Very
Now,
clear.
let's take an example, like a real world example.
Yes.
See, Get this example, so you can complete this part. See, so first here we have this class person. Person is a class. That person is from India. Okay, and
Mhm.
that person is breathing. Okay, that person is breathing. I am breathing here. Then we have another class employee. That particular person, now this employee inherits from the person class, which means this particular employee is from India. Okay, because it is inherits the property of the person class. This employee is from the India and it is also breathing. Okay, it is alive. This person is alive. Employee is alive. And this employee is working in the company Honda and the person is getting some salary and the person is also breathing. Now you can see we have two functions here, take, breathe and take, breathe here. So we have two functions. In the person class, the first parent class, a grandparent class, we have I am breathing. But in the employee, we have the same function saying this line, I am an employee, so I am luckily breathing. So we have this second statement here. So this statement is changing this particular previous statement. Then we have a class which is a child class. So let me mention here. It is a grandparent class. Grandparent, or we can just base class, or we can say a parent class. This is a parent class. So base class and derived class both. Then we have programmer here, which is child class, which is simple a derived class. Okay. Now we have this programmer here. Programmer is an employee. Okay. Programmer inherits from the employee class. And this programmer is also getting some salary. But here you can notice the employee is getting some salary here. So we have this get salary and we have some salary here. But here we have the same function get salary, but this employee, this programmer is not getting any salary, which is no salary to programmers. And we have another function here, take breathe, which is I am a programmer, so I'm breathing here. So we have three functions, like take breathe in the first part also the grandparent. Here also take breathe and here also. Each and every class is stating their own statement. Then is get salary. In the employee, we have some salary here. And in the where the salary is coming from, I think we have to select those. I think we have to add a salary there. So we are having this salary. And then we have this breathe here. So this one is breathing and this one is also breathing. Now we have a class person. Okay, the first class is person and that person is breathing. In the person, we have just one function which is a take breathe. So the person can only access its country and this class. Sorry, this function. Okay, now employee can access the company, employee can access get salary, employee can also access its own take breathe function, and employee can also access the country of the person. Okay, so here we have this employee class. The employee can access its own take breathe, and also the employee can access e company. Also, the employee can access e dot country. Country is coming from the grandparent class here. You can see, but employee can access it. Okay, so let's run this up to here. We have this E class person and we have this E class. You can see I'm breathing here. I am an employee, so I am luckily breathing and Honda India. So this is from the this three parts from the parent class, and I am breathing just from the this grandparent class. Then at last we have this another object which is PR programmer. Programmer is also breathing, and programmer can access the company and programmer can access the country also. Country is coming from the grandparent, but programmer is a child class. It can access. So you can see where this uh, company is Honda. Let me save it. Okay, so company is Honda and Indian. I'm a programmer, so I'm reading plus plus. So here you can see we have this company and country here. Now, what we can do, let's say in the programmer we have another company. The programmer is working in another company. Let's say Fiverr. So now what company is programmer working? Not Honda, in the fiber. So we can run this. You can see in the fiber. So we can change the variables, we can change attributes, we can change functions and so on.
Mhm.
Is it clear?
Yes, teacher.
And in the programmer, we have this get salary. So let's access this also. Here,
Yes.
dot get salary. So the programmer is getting no salary, which is no salary to the programmers. Same as this employee can access its own get salary. This one. So we can use here dot get salary. And here we have this salary, which is 45500. So you will see I am yeah, I think it is returning or printing. Yeah, print F salary. Get salary. Why it is not printing? Employee. Yeah. It is salaries. This function. So this is coming from the parent class, employee. And this one is coming from the programmer class, which is no salary to programmers. So this is an example of a multi-level inheritance. Is it clear?
Yes, teacher.
So
Clear.
I have one question for you. Okay.
Yes, teacher.
Now I have one question. No. First question is from the single inheritance. So in the single inheritance, you have to create a class. Okay, let me write. Create a class. Um, Student. Okay, create a class. Let's say student. And in this class, in the student class, you should have two functions. Okay, let's say function morning for wishing good morning, and second function is for afternoon for wishing good afternoon. So you will have a class student, and that class will contain two functions, morning and afternoon, which will wish teachers good morning and good afternoon. Let's say you can print good morning only, and in the afternoon function you can print good afternoon. That is a class, and then create another class from student. Sorry, create another class. Let's say class name should be any class name you can mention. Let's say we can let's say subject. Okay, in the class subject, you should have again one function which is favorite subject. Okay, now this subject class can access the afternoon and good morning and afternoon functions from the class student and print it. Okay, so you have to create two classes. First class is function. Sorry, first class is student, which will take two functions, morning and afternoon. Okay, which will just print good morning for the morning function, after good afternoon for the afternoon function. That is the first class. Second class, we have this class subject. In the subject class, we have one more function, which is favorite subject. And you can print their favorite, my favorite subject is Python, or you can print anything you want. Okay. But this subject class can access the morning and afternoon functions from the student class. Okay. Is it clear the question?
Yes, teacher.
Okay, so try to do it for by now. If you want to share your screen, you can also share your screen.
Yes, teacher. First, teacher, can you scroll up again, teacher, with your
Yeah.
uh
So I can put an example of single inheritance here. Just a
mm-hmm.
second. So this is an example of single inheritance. Okay.
Okay,
This is
teacher.
the question here, the question, and this is the answer.
Yes, teacher. Okay, let me do it, teacher. So this is a new file. It's what you call this? Oops, advanced, yeah. Advance. Oops. UI. UI. Okay, let me share my screen. Okay, thank you, teacher. So now it's a class student and then define the dance in good morning. And then mhm, on the second class. Second class is subject by subject, then define um, display. Oh, 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 okay, and then now for this one I need to add the student. Correct. Now I can print like just oh, it's a subject. Child display. Yes. And yes. Okay, so that's fun. Yeah. Subject. Yeah, the fun and uh, and now the S display. S display. Okay. Single inheritance. Okay, now I can display. Control S. Now what happened? Line 2. Here. S.
Is
Yeah.
it completed?
Yes, teacher. So let me show to you, teacher.
Yeah.
Oops. Okay, so let me share my screen with this. Do you see my screen, teacher?
No.
Oh no, wait. Subject. And then S display. Self, good morning. And then the fun. And then S display. Okay, up this one because of my paper subject is Python. Oh, see it. Oh. So, so it replaced from the good morning to, oh no, this one's incorrect. Sorry, teacher. That's why.
Can you share screen?
Oh, yes, teacher.
So you have the class student and you have as display one. Okay, good morning, good afternoon. Okay. If subject here student, okay, as display. My favorite subject is Python. Okay, here you can see you. It is not compulsory to make as display again in the class subject. I have, you can create another function, but it is okay. For now, it is okay. Just leave it. The syntax is correct. Then you create
Okay.
object, the subject. Okay, it is also good. Dot display. My favorite subject is Python home front. Yeah, exactly. It is right. It is correct.
Correct, teacher.
Yeah. In line number 14, just remove this line number 14. Okay, because you have already printed the S display. Yeah, it is correct. Well done. Yeah.
It is.
So
Yeah.
this concept is clear, right?
Yes, teacher.
Okay. Now we can move to the next concept, which is polymorphism.
Yes, teacher.
Yeah. Yeah. So now we have this concept of polymorphism. Now, what is polymorphism? It is like means having the word polymorphism means having many forms. In programming, polymorphism means the same function name but different signatures being used for different types. For example, let's say we have the function, we have this plus here, right? In the Python, we have plus here. Now this plus is same, okay, but this plus can do multiple operations. This plus can add numbers, like 4 plus 5 in Python. And this plus can also add strings. Okay, like hello. plus world. So you can see we have this plus. Plus is the same number, same name. You can think it is the same form. It is of the same form, same name, but performing different operations. So this plus can perform two operations like add numbers and add strings. So it is an example of polymorphism. Okay, so polymorphism says having many forms, like same function name, but different operations. Okay, different signatures. Okay, that is only for polymorphism. For example, this example you can look, it is again an example of a polymorphism. For example, get this len here. In this len, now length function, right? Now this length is used in the string also, and this length function can used in the list also. So this length function will tell you the length of the string which contain 3, 4, 5 character. And this length function can also contain this length function can also be used in the list which contain 3 elements. So you will have 5 and 3. Okay, 5 for the geeks, 3 for these element. So here you can see this is an example of a polymorphism. Polymorphism means same function doing different operations. Same function name doing different operations on different data types. Okay, just think of same name but different operations. Or we can say same name using multiple, can be used in multiple ways. So this len function is same and this len function is same, but where are we using? We are using in multiple operations. This is we are using with a string and this is we are using with a list. That is all about polymorphism. It is a very easy concept. Okay. Now let's take another example. So let's take, we have two types of polymorphism. In the polymorphism, we have two types. First, we have overriding. Now, what is overriding? So let's create a program first. So we have overriding and we have overloading. So let's say we have a program here, class parent. In this class, we have def, let's say trans. Okay. Which means transport. Let's say we have trans. Now parent use bike for the transport. Let's say. Okay. Parent uses bike for the transport. Then we have class child, which is inherits from the parent class. Okay. Now this child is using for like car for the transportation. Okay. Now we can create an object here, which is object 1 equal for the child. And now we can print object 1 dot transport. So which object will be printed? Car here, because child is now using car, not bike. If there's no, like if there's no function here, then child is, let's say if there's no function here, we can use, let's say, pass here. Now, what kind of transport the child is using? Bike. Okay. So now child is using bike. But here the child is modified and it is now using, that child is using car. Okay, it is using car. So this is an example of a overriding. Why overriding? See, let me remove this. So this is an example of overriding, which means we have same functions, but we are overriding the functions, which means we are rewriting the function. The parent using transport for as a bike. Okay, for transport, parent using bike. But when the child inherits from the parent class, the child is using the car, which means you can see they're like same function name. Trans and trans. Transport is the same function name. Here we have the same function name, but we are overriding the previous function. So child is overriding, which is overriding the previous parent function, which is trans here. So child has updated its transport vehicle to the car. So this is an example of overriding. Child is overriding the previous function of the parent and updating to the car. Okay, that is an overriding here. It is very simple, just rewriting or updating the previous parent function to the new function. Okay. Then this is an example of overriding. Overloading is like the example which I have provided you. Let's see, we have this print here, 5 plus 5. Okay. What is 5 plus 5? 10 here. So this is adding numbers. This plus operation is adding numbers. Same as here, we have numbers. Hello. Sorry, we have string hello world. So this is overloading. Overloading means same function, same name, but different operations. Different operations. This is overloading. we have this 5 plus 5, 10, and hello plus world, hello world. So if I run this one, you will notice 10 and hello world, which means 10 here is this plus operator will adding numbers also, and this plus operator is also adding strings. So this is an example of overloading. So here I can write this is adding numbers, simple adding numbers, and this is known as concatenation. Okay, concatenating the native strings. So same function but different operations. That is polymorphism. So we have two types of polymorphism: overriding and overloading. Let's see this example. This is a big example. This is an example of a I think there's some mistake here. Yeah, so this particular is an example of a overriding. Okay. And this is an example of a overloading. Let me copy this. So this is another example of a overloading. We have same name but different operations. Then this is again overriding. So let me copy this part and bring it here separately. And this is overriding. Let's see here we have this class word. Yeah. So this class word here, here we have this intro here. Intro cell, there are many types of words. Flight here, most of the words can fly, but some cannot. So we have this class simple word. Inside class, we have two functions, intro and flight. Then we have class sparrow, which inherits from the class word. Okay. So we have this sparrow, which is inheriting from this parent class, which is here we have this another function, flight. So this function and this function. Now you can see sparrows can fly. So now this flight function is overriding the flight function of the parent class. In the parent class, which is bird here, we have this function flight. It is saying that most of the birds can fly, but some cannot. But we have another class, sparrow, which is inherits from the parent class. And here we have this same function, flight. But this time, this function is overriding this function, means updating. Sparrows can fly. Same as we have another class, ostrich. And in the ostrich class, we have this flight. And here we can see ostriches cannot fly, which is, again, we are updating the flight function. So it is an example of a...
Yes, teacher.
Here we have this parent class, right? We have parent class, and this is sparrow class child, and this is also child class. So this is another example of an inheritance class, which is multi-level inheritance. Sorry, multiple inheritance. In this multiple inheritance, we have one parent only, but two child here, one child and two child. Okay. So this is also an example of an inheritance, but here we are updating the functions. So this is an example of an overriding also, which is in the polymorphism. We are updating the functions in the child class of the parent class. Okay. And then we can simply run this. So we have three objects, word, sparrow, ostrich, and here we have this object, word here, and here we have intro flight, and for these three. Intro is same only in the every class. There are many types of words, and there are many types of words. But for each class, we have different flight function. For the first, we have this one. Okay, this most of the words. Then for the sparrow, we have sparrows can fly, and then we have this ostriches cannot fly. So you can fly and cannot fly. So this is again an example of an overriding. We are overriding the previous parent class with a new previous parent feature to the new feature. For example, let's say we have the parent class and the child class. Let's say the parent class favorite color is red and the child parent favorite color is black. So this is again an example of an overriding. The child is overriding the parent feature. Okay. Is it clear?
Yeah. So that one
now what we can do, we can take a quick recap, okay, before ending the session, because I think it is enough for today.
Yes.
First, we discussed about the three types of approaches in the OOPS, which is modular, procedural, and object-oriented programming. Till now, we were performing the procedural, which is from top to bottom, creating multiple functions, which have some drawbacks here. But And then we were also following the modular, which is also effective than procedural. Then we have object-oriented programming, which is more beneficial than any other like approach. Here we are dividing the entire program into objects and classes. Then we have discussed about what are classes and what are objects. These are classes and these are objects. Then we discuss about inheritance. Inheritance like inherits the future of the base class or deriving the features from the base class. So we have discussed about single inheritance. We have one class, one parent class, one child class. That is single inheritance. Then we have multiple inheritance. We have two parents and one child. We can also in the multiple inheritance we can also have one parent and two child or two parents or one child. Okay, it can be anything. In the multiple inheritance, we can have two parents, mother, father, and one child, and we can have one parent and two child. Okay, it can be anything. In the multiple inheritance, then we have discussed about hierarchical inheritance or multi-level inheritance. Multi-level inheritance is also known as hierarchical inheritance, where we have the hierarchy of from grandparent, parent, and child. Then we have discussed about the some examples and polymorphism. Okay. Polymorphism is like we have the same name, same form, everything is same, but different feature, performing different operations. For example, this len function. This len function is same name, len and len here, but this len function is working upon on top of string, and this len function is working on top of list here. So this is a polymorphism. It is an example of overloading. Same as we have this example. Let me remove this here. Same as another example of overloading is plus operator. In the plus operator, we have one plus operator, which is same name, same like operator, but performing different operations, working on top of number. One plus operator and second same plus operator is working on top of string. So that is an example of overloading for polymorphism. Then we have overriding polymorphism. In the overriding, we are just changing the class function, child function, or changing the feature of the parent in the class, in the child class. So for example, we have this example, the parent class, we have child class. So parent is using bike for the transportation, but later on the child is using car for the transportation. So child overrides the trans function of the parent class. So this is an example of overriding. Same as this example, in this way we have one parent class and two child, sparrow and ostrich. We have two child here. And we have this two functions. One function is intro and second function is flight. And in each child class, which is sparrow and ostrich, we have flight is overriding this word class. And same as this sparrow flight is overriding this flight function. So this is again an example of overriding. We are overriding the features of the parent class to our own feature as a child class. Okay. So this is all the summary of the this today's session. Is it clear? Any
Yes,
question?
teacher. No, teacher.
Okay. So I will share the video and I will share some questions on polymorphism and this inheritance and classes and objects. So try to solve the questions, and in the next session we will continue with the objects only, object-oriented programming only. Like some concepts are left. Okay.
Yes, teacher. So teacher, you're gonna send the two videos to our teachers.
Yeah, I will share both videos and notes.
Yeah, and notes. Thank you very much, teacher.
Thank you so much, and rest we will continue in the next session. Thank you.
Yes. Have a good day. Bye.